As x goes to plus infinity, the limit of the x is going to be infinity, yes? And limit of 1 over x as x goes to infinity is 0. The limit of sine 1 over x is going to be sine of 0, which is 0. So this is 0, infinity times 0. So what is the trick here? We have to turn one of these guys to 1 over 1 over itself. So I will choose write x as 1 over 1 over x, sine of 1 over x as x goes to plus infinity. And well, that is basically sine of 1 over x over 1 over x as x goes to plus infinity. And if you find the limit of numerator and limit of the denominator, now you see that, oh, by doing that, we turned our limit to 0 over 0 indeterminate form. Now I can use Labtube rule. This is limit of x goes to plus infinity. Derivative of sine of u is u prime, so derivative of 1 over x, which is negative 1 over x squared, cosine u. Derivative of 1 over x is negative 1 over x squared. You can go ahead and try to find 0 over 0, it will be 0 over 0, and you can go ahead and do L'Hopital rule. But every time that you do one of these L'Hopital rule, if there is a chance to simplify, simplify it first. Here I can delete negative 1 over x squared by negative 1 over x squared, or cancel in the numerator and the denominator. So this way, my limit turns just simply to limit of cosine 1 over x as x goes to plus infinity. Don't confuse this limit by limit of cosine 1 over x as x goes to 0. Limit of cosine 1 over x as x goes to 0 does not exist, but limit of cosine 1 over x as x goes to infinity is cosine of 0, which is just 1. Let me do the other one. Here, as x goes to 0 from the right, remember the graph of ln x. Graph of ln x is something like that. As x goes to 0 from the positive side, the limit is negative infinity. And the limit of the x squared is going to be 0. 0 times negative infinity. We can either write ln x as 1 over 1 over x, or write x squared as 1 over 1 over x squared. Here, 1 over x squared, 1 over 1 over x squared will work better. And as you can see, this time I have turned my indeterminate form to infinity over infinity. And again, I can use L'Hopital rule. Replace the numerator by the derivative of the numerator. Replace the denominator by the derivative of the denominator. Now I can cancel first. This is important. And I can write that this guy is limit of 1 over negative 2 over x squared as x goes to 0 plus, which is the same thing as limit of x squared over negative 2 as x goes to 0 plus. That is going to be just one nice 0. So these were examples of product indeterminate forms that I turned them to 0 over 0 or infinity over infinity and resolved.